Hi, my name is Peter Wilder. I'm an HVAC application engineer at ABB. The following presentation is going to discuss setting up a PID loop with two feedback sensors connected to an ACH580 drive. Now, most of the time when you set up a PID loop on a VFD, you only have to connect one transducer or feedback sensor to the drive. But there are some applications that require two sensors to be connected to the drive. The good news is the ACH580 drive has two analog inputs, so both sensors can be connected directly to the VFD. Now, a common application where you'll need to connect two sensors to a VFD is a stairwell pressurization fan application. In the image on the right here, I've depicted a 4-story building with a VFD and motor on top, and a transducer on the 4th floor and one on the 2nd floor. In the following video, I'm going to teach you how to program the drive so it can be set up with both sensors connected to the VFD. In the video, I'm going to have the transducers have a range of 0 to 1 inch of water column, and I'm going to have a set point of a 1/2 inch of water column. I'm also going to set up the VFD so it takes the average of both transducers. I will also mention in the video that it is not uncommon to also maybe take the min or max of either transducer and regulate the PID loop off of that instead. Starting from the home screen, we're going to select Menu. We're then going to select Primary Settings. We're then going to navigate down to PID Control. In this setup, we're going to actually use the list of PID adjustments down below. We're not going to use the PID Assistant. So I'm going to select here, Use PID Control. We now need to select where does the run stop command come from when we're in auto mode running the PID loop. Most likely, your selection will be the same as mine, which is digital input 1. We next need to adjust the units. We're not degrees Fahrenheit, we're doing inches of water column. Now, we need to make an adjustment for one of the analog inputs, which is one of our feedback sources. In here, we're going to adjust AI2. Now, in my setup, I have 0 to 10 volts as my feedback transducer, and I don't have 0 to 200 inches of water column. I have a 0 to 1 inch of water column. So I need to adjust the maximum setting here for the range of the transducer. So go from 200 to 1. So now I have min is 0 inches of water column, and my max is 1 inch of water column. Then back out of here. Now I need to adjust my set point. The set point in our example is going to be a 1/2 inch of water column. So we're doing a constant set point also, which is just a fixed setting programmed into the drive parameter. So I'm going to adjust the 75 here. To 0.5 inches of water column. Now, I'm not going to go into the tuning menu here, but this is where you'd make adjustments, for example, to your integral and gain to help speed up or slow down how fast the drive reacts to changes in the feedback source. This is something that would be adjusted after the basic PID control is set up and the drive is operating correctly based off of the two transducers. We now also need to adjust how the drive reacts to the feedback signal being greater than or less than the set point. Sometimes this adjustment in the industry is called direct or indirect. In our setup, we want the drive to accelerate the motor when the feedback is less than the set point. So we need to make an adjustment here, feedback less than set point. This means the drive will increase the speed of the motor, and when the feedback signal is greater than set point, the drive will slow the motor down to a stop. Now, the next option that may also need adjusting along with tuning after the basic PID loop is set up is a sleep function. Sleep function, I'm not going to go into detail here, but the summary is as the drive's feedback signal gets close to the set point, the drive will start slowing the motor down. And if you don't want the drive attempting to run the motor, for example, at 5 hertz endlessly, as the feedback signal is very close to set point, you can set up a sleep function in the drive to say just shut off. Stop operating if, for example, you're running the motor at below 20 Hertz for more than 10 seconds. Now, after this, we need to back out of primary settings and go back to the main menu here. We now are needing to navigate to the main parameter list to make the final adjustments. Go to complete list. Now, the first adjustments are going to be made in group 12, standard AI. We need to set up the second analog input source. We adjusted AI2 already, but now we need to adjust AI1 as that is connected to our other transducer. Here you can see we have our scaled analog input min is 0, which is what we want, but our max is 60. We want to edit this to 1.0. Now, if you have a transducer, for example, let's say that's -1 to +1 inches of water column, you would want to make adjustments here. For example, on AI1, you'd want to make this, for example, -1. So that when you have 0 volts, that would correspond to -1, and you had 10 volts, that would correspond to +1. In our example, we have 0 volts is corresponding to 0 inches of water column, and 10 volts is corresponding to 1 inch of water column. The next adjustments are going to be made in group 40. Here you can see we have one of the feedback sources connected to analog input 2. We now need to set up the other one to analog input 1, scaled. We want to make sure we do scaled and not percent, because we want to make sure that we're following the 0 to 1 inch of water column setting. The next setting is which feedback sensor are we following. By default, the PID loop only follows one of the sensors, but we're going to select the average. We want to take the average of the signal coming into AI1 and AI2. Now, in your setup, there is a good chance you may select, for example, the min or max setting. This means the drive will look at both analog inputs and it will say whichever one is the minimum, that's my feedback source, or whichever feedback source has a higher value, that is my feedback source. But like I said, we're going to select average. We're going to take the two sensors and average them together. Now, the final setting we need to adjust, because we're doing two feedback sensors into the drive, I recommend you adjust parameter 4014 to the maximum value of your transducer range. In our case, it's a value of 1. We have a 0 to 1 inch of water column, so I'm going to adjust parameter 014 set point scaling to 1. This is not adjusting the set point that is programmed in the drive. This is adjusting some scaling behind the scenes. I just recommend you adjust it to the maximum value of your transducer range. Now, this completes all the programming in the drive. Now, to accept 2 analog input signals or 2 feedback signals for your PID loop. Now, one of the cool tricks is on the home screen, obviously we have output frequency, current, and your analog input value and voltage. If you click the left button here, we have pre-canned PID setup menu. You have your set point on top, that's a 1/2 inch of water column, that's correct. We have our feedback here, and we have our output frequency. Well, if you think about, we want to know, we have 2 transducers. So this normally would just represent the one transducer, it would be good. What are both my transducers at right now? I pre-set up initially here for this presentation another menu, and you can do this, make these adjustments by clicking options and going to edit home view. As you can see here, I have AI1 scaled on top, and I also edited the text to add inches of water column, and I have AI2 scaled in inches of water column, and then I have the feedback. So the bottom value is the combination, the average, because that's why I selected the average of both AI1 and AI2. As you can see, I have 0 and 1 inch of water column. The average of that would be a 1/2 inch of water column. Now, what I'll do is I'm going to adjust analog input 1 to be a 1/2 inch of water column, and let's verify that now my process feedback goes to 0.75 inches of water column. Good. It's a good idea to always make sure you check your process feedback is accurate and ranging correctly after you set up your PID loop. Now this concludes this presentation. If you have any further questions related to this presentation or anything else related to ABB drives, please reach out to your local ABB representative and they can assist you with your questions.